Hello, Assalamualaikum to Syekh. I'm Muhammad Fikry bin Kamarulzaman, your first presenter. And in this video, me and my friend, which is Amira and also Maziah, will present to you about some reaction of organometallic compound. Let's get into it. This slide is about organometallic compound undergo a rich variety of reaction, which may involve loss or gain of ligand or both, the molecular rearrangement, formation or breaking bonds to the metal or to the ligand. Alright, A, show the substitution reaction in carbonyl complex, which is the typical substitution reaction. And as you can see in this slide, this is the general equation for substitution reaction. This reaction represents an important way to introduce a new ligand. And this type of reaction does not involve any changes in the formal oxidation state of the metal center. Next slide is the kinetic studies of the reaction indicate that the substitution reaction may have either an associative or dissociative mechanism. First example is the associative mechanism, which is the metal ligand added with a new ligand in the slow step, then one of CO ligand being removed and replaced with the new ligand. That is the fast step. The rate of determination step, which is the slow step, involve a bimolecular reaction of metal ligand and the new ligand to form an intermediate reaction. And below it is the example of dissociative mechanism, which is we remove one of the CO ligand from the metal ligand in the slow step, then a new ligand being added to the metal ligand that we have in the fast step. And the rate determination step involve the splitting of one reactant to form two products. The product then react with the substitution ligand in the fast reaction. Although most substitution reaction proceed primarily by a dissociative mechanism, an associative path is more likely for complexes. It having large metal will providing favorable site for incoming ligand to attack, and it is highly nucleophilic ligand. Insertion reaction. Many reactions in organometallic chemistry involve insertion of small molecules, such as X bond with Y, involve metal ligand bond, especially M bond with C and M bond with H, which is metal with carbon and metal with hydrogen bonds. Although some of these reactions are believed to occur by direct or single-step insertion, many such reactions are much more complicated and do not involve a direct insertion step at all. Alright, the next slide will be continued by my friend. Thank you, that's all from me.
Assalamualaikum and hi everyone. I'm Nur Amira. Okay, so let's move to the next slide. Basically, there are two types of insertion reaction, which first insertion is insertion on bond occur only on one atom. Okay, second insertion bond occur between the two different atoms. As you can see from the example that have been given in the slideshow. Okay, the Mn metal is bonded to the 5-carbonyl and CH3 will be added with another carbonyl, and then the Mn metal will bonded to the C of the new carbonyl and form C double bond O. Okay, CH3 will bonded to the new carbonyl. Okay, second insertion is about the insertion bond occur between the two different atoms adjacent to each other. For example, CO cobalt metal. Okay, cobalt metal is bonded to 4-carbonyl and 1H. Okay, added with F2C double bond CF2 ligand. Okay, the cobalt CO metal will bonded to the C of the F2C double bond CF2 Okay, the double bond between the C and C will form single bond, and then one H will be bonded to C. We will look at how small molecules such as CO2 and SO2 insert into the metal-carbon bond in the organometallic compound. Okay, for the CO insertion, carbonyl insertion, also known as carbonylation. It is found that when the carbonyl react with organometal CH3MnCO carbonyl 5, product was CH3CO MnCO5. It seems that carbonyl has inserted itself between the Mn and CH3 bond to produce an acyl complex. Okay. However, upon the further investigation, when level 13 carbonyl was used, product was found to be CH3 carbonyl Mn CO4 13 carbonyl. The conclusion of this study are okay. The incoming carbonyl added the Cs into to the acyl group. Okay. Any other Lewis base can also bring about carbonyl insertion as shown in the mechanism below. As you can see, the conversion of alkyl into acyl can be affected by the addition of ligands such as PPH3 or any Lewis base. As you can see, the Mn metal is bonded to the 5 carbonyl and methyl. Okay, methyl plus with the solvent. And then the CO, okay, the incoming CO will insert itself between the Mn and methyl to form into acyl complex. Okay, and the solvent will leave the complex. Okay, another ligand can be bring about into the CO insertion. So the incoming CO is inserted between the Mn and methyl group to form an acyl complex. Okay. Unlike carbonyl, SO2 insert directly into its metal carbon bond as shown in the reaction below. Okay, like for example, metal and carbon, okay, are alkyl, okay, and then S will bonded SO2 will bonded to between the metal and C alkyl, not between the metal and alkyl group. It is between metal and carbon group as double bond O. Okay, the product of an SO2 insertion can also vary as shown below, like metal and R. For example, like CO, CC, CO, CH3 methyl. Okay, it will insert itself between the M or CH3, or the CH3 will bonded to one O of the SO2, or it will bonded to S, or it can form the peroxide. That's all from me.
The coordination number of metal center increase in the SO2 insertion reaction, but it does not involve any changes in the formal oscillation state of the metal center. Therefore, it has classified as a simple addition reaction. When the increase in the coordination number is accompanied by an increase in the oscillation number of metal center, the reaction is classified as an oxidative addition reaction. So we go to the oxidative addition reaction and also known as OA reaction. It has a low valence transition metal complex react with a molecule XY to produce another complex with both the oxidation number and coordination number of metal increase. Usually, both the oxidation number and coordination number of the metal center increase by 2. So, for this OA reaction to occur, the metal center must be D2 or greater. Also must be coordinatively unsaturated. For example, can still accommodate addition 2 more ligands around it. Next is metal center must have less than 18 electron. Compounds already having 18 electrons will not add more ligand because doing so will violate the ion rule. Next is metal center must have both appropriate and empty orbitals to accommodate the donated lone pair of electron. Okay, this is the example of center metal and ligand. So, as we can see, there is a decrease in the electron density on the metal as the reaction proceeds, which lower the pi back bonding from metal to the CO. This effectively increase the bond order, hence strength of the CO bond. This increase in the CO bond strength is reflected in the IS ranging frequency of CO. That is from 1967 to 2075 cm -1. So on the explanation just now, here is the example of oxidation addition reaction, also known as OA reaction. So the metal complex react with molecule XY to produce other complex. Next, we continue with reductive elimination and also known as RE reaction. The opposite reaction to oxidative addition is reductive elimination, where the opposite happen in this reaction. Both the oxidation number and coordination number of metal decrease with elimination of ligands, such simple molecules such as R bonded with H, R bonded with R prime, R bonded with X, and H bonded to H, where R and R prime is alkyl and aryl, and X is a halogen. As we can see, here is an example of an reductive elimination reaction.